Alright, this is a lesson for Algebra 2, Lesson 5, Simplifying Radicals, but we're talking about algebraic radicals. So now we're introducing the letters in there, the variables, okay? So, which could be positive or negative numbers, so we don't know they're variables. And we're going to apply the same concepts we learned on Friday with remember the whole story about the prison? To break out, you have to look at the index, they group up in that group, and then they break out. One only makes it every time. Okay, so that's what we need to know from last time. Steps are still the same. Oop, excuse me, sorry about that. Go back here. Steps are still the same. Okay, watch me do numbers 1 and 2. Number 1, 98m to the 4th power. Okay, the first thing I'm going to do is look at my index and radicand. The index here is 2. I could assume that. Radicand is nm to the 4th power. There's a little multiply sign between the two terms here. So first thing I do is make a factor tree of 98. 98 is even, so I'm going to factor out a 2 times 49. And I know 49 is a perfect square, 7 times 7. So when I factor out 98, I know it's going to be 2 times 7 times 7. And then m to the 4th is going to be m times m times m times m, okay? So that's the way we've learned how to do it so far. Put the square root sign over the whole thing. Since the index is 2, anything has to pair up into groups of 2. So we know that the 7s, these two 7s pair up, they try to get out. Only one of them makes it. The other one doesn't make it. A couple of m's get together here. Only one makes it out. The other one doesn't. Same thing here. Only one makes it out. So the only people that made it out of this square root sign was the 7 times the m times the m. And we still have the square root sign. The 2 didn't make it out. It didn't have anyone to pair up with. Simplify, we got 7m squared. All to the second, or times rad 2, okay? So that's number 1. So what did I just do here? What did I just do here? So the first thing I did was the following. Watch again. First thing I did is I factor out 98. I know 98 is the square root, or is 2 times 49, and I know that 2 is prime. 49 is 7 times 7, so those are both prime. So I rewrote the factored version of the radicand, okay? Then I paired up 7s, the m's, and the other set of m's, and then I rewrote it. So we still got 7 times m, square root of 2. Simplify, we got 7m squared rad 2. Okay, that's number 1. Okay, watch me do number 2 now. Number 2, we know that the index is 4, so we got 4th root of 64x squared. So first thing we want to do is factor out my radicand. We're looking for groups of 4 now, okay? So we got 64, we could factor out as follows. 64 is like saying 16 times 4. But we don't have any groups yet of 4, so we got 16 is 4 times 4, and then each of these 4s is 2 times 2. Again, we're looking for groups of 4. So we have 6 2's, okay? So we're going to rewrite the 3 on the outside, the coefficient. We got the 4th root of 2 times 2 times 2 times 2 times 2 times 2 times x times x times x times x times x times x. Okay, so 1, 2, 3, 4, 5, 6. That's a lot of x's. I'm going to show you a shortcut in a moment. So now we group them up in groups of 4, just so that you remember how we did it last week. So these 4 2's try to get out. Only one makes it out. The other 3 don't make it out. These other 2's, we can't take them out, so we're going to leave those alone. Then we have 4 x's here. 3 of them don't make it out. 1 of them does. And then these other 2 x's don't make it. So now we're going to simplify. We're going to write 3 times 2. One of those 2's made it out. Then we have one of the x's that made it out. And then we have the 4th root of 2 times 2 times x. Last step, we're going to simplify. We got 3 times 2 times x is 6x times the 4th root of 4x squared. Okay? So the last thing I want to do is make sure that I check on each of these, make sure that looking at the original problem is positive on the inside. I took out 1x. So what if this x is negative? Will it make my problem negative? Yes or no? Yeah, it would. Okay, so we don't want it to be negative. So, because if I put a negative back into here, then it would change the whole problem. So we don't want that, so we're going to put absolute value signs around the x here. Okay. Absolute value signs make things what? Positive, right? So we want to make sure that's there. All right. One more shortcut. I'm going to show you how to do this number 2 a little bit quicker. We don't want to write all these 2's and x's out next time, so what's an easier way to do it? Let's say we're going to look at step number 2 here again, right here. Okay. So instead of writing all that out, I could have written this instead: 3 times the 4th root of x to the, I need groups of 4, so I could have written 2 to the 4th times 2 squared times x to the 4th times x squared. So I would have grouped my x's and my 2's together. I could have circled my 4, or 2 to the 4th, crossed out the 4, brought it across, and then I would have known that the leftover was still there. Okay, so I could have still continued 3 times 2 times x to the 4th root of, oh, that's not 4th root, to the 4th root of 2 squared x squared, which is 4x squared, and then finish my problem. So you see how that's a little easier to go? You're not writing everything out. Did y'all notice that? And then we got 6x, same answer. So this is just a shorter way to do number 2. Okay? So what I'd like you to do, 1 solid 2 is about number 1, 2 solid 1 is about number 2, okay? We're going to have the 1's go first. Ready, set, go. Okay, number 3. Number 3 and 4 are very similar, so if you didn't get it right the first time, we'll try something a little bit more difficult, number 4. Okay, number 3, go. On your iPad, you can discuss it with your neighbor. You know, go step by step, work together. Okay, go. Number 3, the way I would do it, factor out the 32. So we know 32 is just like saying 16 times 2, and then 16 is 4 times 4. I'm looking for a pair of numbers because our index is 2 in this case. So we know that 32 is like saying 4 times 4 times v times 2. Right? We know that the v and the 2 won't make it out, so these 2 4's will make it out. Only one will make it out, the other one will not. So we got 4 times 2v. That's your answer. Okay? Somebody had the v on the outside. That was incorrect. Okay? Make sure you correct that on yours. Number 4. Try again. This one's going to be a little bit different. Go. Number 4. Oh, I'm sorry. Number 4. On number 4, right, it's very similar to the last one. You should have had 4x rad 2. Now, you always ask yourself at the end of each problem, okay, look at the original problem up here. Is my original radicand positive or negative? Positive, right? So I took out an x here. What happens if this x here is negative? Will it change my problem? Yeah, so we have to make sure that, we want to make sure that this is positive because our original problem is positive, right?
So every time there's a variable
that you pull out,
you have to put those.
Not every time, sometimes it doesn't apply. Because you have to think about what happens if the inside's negative, and you want this to be negative, right? So then you wouldn't want an absolute value sign. Does that make sense?
So only if the inside's negative?
Yeah, if the inside's negative and you pull it out and you want it to be negative, then it should be okay. Okay? But sometimes you want the inside to stay positive, so we want to put the opposite value sign. It's kind of a confusing topic. We're only going to touch on this unit, and then we're kind of done with that. So don't be totally upset about it. Yep.
If the inside is negative and you take it out, would you write it as negative on the outside, or would you leave it?
It depends what the radicand is. So sometimes you have to factor out. Remember last Friday we factored out a negative sign, a -1. So it depends. Yeah. It depends if the variable could be positive or negative. So it really just depends. Yes.
If we don't show off the x there, would we get it wrong?
Yes. Because on the test, it'll show an example with the absolute value sign and then an example without it as your answers, okay? Okay, you're welcome. Number 5, go. Okay, so don't erase your boards. Number 5, you would have factored out, 48 is going to be, what is it, 12 times 4. It doesn't matter which way you go. You could have done 16 times 3, but we know 12 is 4 times 3, and each of these 4s is 2 times 2. We could circle each of those. 2 and 2. Prime factors, right? And we need groups of 4, right? So on this one, we're going to have 2, 4th root of 2 to the 4th times 3. That's the factored version. I'm doing the shortcut method. Times x to the 4th. We know that these 4 2's could be grouped out and taken out. Okay, so we got 2 times 2, and only one of the 2's makes it out of that group. The 3 doesn't make it. We just leave the 3 in there. And then the x to the 4th gets taken out. All of them get taken out except for 1. So there's one of these x's that makes it out. So we got 4th root of 3, okay? Then we simplify, we got 4x, 4th root of 3. Okay, now I got a question for you. Is the x on my original problem, is my radicand positive or negative? Positive. So what happens if I have this variable's on the outside now? What happens if this is negative? Can it be negative? No. So what should we do to put around it? Yep, we got to put some. A lot of you didn't do that, so please make sure you got that. Okay, that's number 5. Here we go, number 6, last one. Looks scary, but it's not too scary. Go. Again, 512. 512 is 2 times 256. We know 2 is prime. 256 is 16 times 16. Or it could even be 64 times 4. I don't know. It depends what you want to do. Okay, go. That's your hint. Okay, so on this particular one, I'm going to keep factoring here. I need groups of 3, so I have 1, 2, and I know if I take this 4, I can get 2 more 2's, right? 64 is like saying, what is it? Or it could be 4 times 16. So, and I know 16 is 4 times 4, right? So I kind of make my factor tree work it out. I could have done this whole thing, by the way, 512 is 64 times 8. So, anyways. So, it doesn't matter which way you go. So, we got 7. I'm going to rewrite this. 7 times the cube root of, and then I have a few factors here. We got 4 to the 3rd times 2 to the 3rd times, is there anything left over? No, that's it. Times b to the 8th. Now, I want it in groups of 3, so 8, I could divide 8 b's into 2 groups of 3, so it could be b cubed times b cubed times b squared. Okay? Continuing on here, we know that 4 to the 3rd, we could take out this group, this group, this group, this group. Each of these cancels out except for one of each. So we have 7 times 4 times 2 times b times b. And then on the inside, all we're left with is a cube root of b squared, okay? So that didn't have enough. 7 times 4 is 8 times 2 is 56. B times b is b squared. We have cube root of b squared. Okay, now I have to think about this. On this example, this one's a little different. So, is it positive? Yes or no? Then I ask myself, what happens if the outside is negative? What happens if I have a negative exponent here? Or a negative, not a negative exponent. Negative sign in front of the b. What's negative times negative or negative squared? Positive. So, does it matter if there's a negative in the front? It doesn't matter. So do I have to put absolute value signs? You could, but it's redundant. So that's your answer. You could just leave it alone. You don't need them there. And that's it. Okay, so this concludes our lesson. Oh, I'm sorry. So what I'd like you to do is